Look up on a perfect summer day, and you'll see them floating up there like giant, gentle puffs of cotton. We're taught early on to think of clouds as weightless collections of mist drifting on the breeze. But that innocent-looking fluff is holding a massive secret. A single standard cumulus cloud like this one actually weighs tens of millions of pounds. Which brings up an obvious, almost unsettling question. If that cloud is heavier than a fully loaded fleet of commercial airplanes, why isn't it crashing down on our heads? The answer takes us deep into a hidden atmospheric engine. It's an engine that builds towering structures powerful enough to spawn tornadoes and generates bizarre sky phenomena entirely out of dead shooting stars. Dropping the childhood illusion of weightlessness reveals clouds as massive physical engines that silently dominate the Earth's surface. The architecture of a cloud starts with microscopic pieces of Earth called aerosols. These are tiny, floating particles of desert dust, sea salt, or even wildfire smoke. Without them, a cloud actually cannot form. When the sun heats the ground, it energizes water molecules in oceans and lakes, turning them into a gas called water vapor. Those vapor molecules ride the rising heat upward, colliding with and attaching to those suspended aerosol particles. The result is a newly formed cloud droplet, but it is incredibly small, only about 20 micrometers across. It is less than 1,000th the size of an average raindrop. Because they're so exceptionally light, the upward push of warm air easily keeps them aloft. Buoyancy is ultimately determined at the atomic level. Most of our air is made of nitrogen. A molecule of water vapor actually weighs less than a nitrogen molecule. So these tens of millions of pounds of water aren't magically hovering. They are actively trapped aloft by thermal updrafts and the hard math of atomic physics, turning the sky into a massive, pressurized suspension tank. If you travel 40,000 feet straight up, the environment shifts drastically. Here, the temperature drops to a bitter -71 degrees Fahrenheit. Any liquid water instantly freezes into razor-sharp ice crystals, forming these thin, hair-like cirrus clouds. Push even further to the absolute edge of space, 50 miles above the ground, and the physics get truly bizarre. Clouds still exist up here, despite the fact that there is almost zero native water vapor at this extreme altitude. These are noctilucent clouds. Sitting so high up, they catch the sun's rays long after sunset, shimmering like electric blue curtains against the night sky. Since there's practically no dust up there, these extreme high-altitude clouds rely on an extraterrestrial anchor. When meteors burn up in our atmosphere, they leave behind trails of incinerated smoke. The sparse water droplets freeze directly onto that debris. Down near the surface, extreme heat creates its own atmospheric monsters. When an intense wildfire burns through a forest, it releases massive amounts of smoke and superheated gas, birthing a cumulonimbus, a towering fire cloud. These smoke clouds generate internal updrafts so powerful that they build their own volatile weather systems. These monster storms can unleash localized windstorms, hurl dry lightning strikes that spark fresh fires, and even spin up fire tornadoes. Whether catching the light of dead shooting stars or feeding off a forest fire's extreme heat, clouds in these extreme environments become direct extensions of the specific forces that birthed them. All clouds eventually reach a breaking point. When millions of tiny cloud droplets merge together, they finally become heady enough to overcome the atomic buoyancy holding them up, and they plummet back to Earth as precipitation. Inside a towering cumulonimbus thundercloud, this process is incredibly violent. Massive columns of warm air rush upward, catching water droplets and repeatedly hurling them miles into the freezing upper layers of the storm. Every time a droplet gets tossed back up into the freezing zone, another layer of ice forms around it. This violent looping creates hailstones that grow larger and larger until chunks of jagged ice the size of baseballs come crashing out of the sky. Under the right conditions, these thunderclouds become supercells. When colliding wind layers hit the storm from different directions, they force the entire structure, tens of millions of pounds of airborne water and ice, to begin rotating. That rotation is exactly what spawns tornadoes. You might assume a gloomy, heavily clouded sky would be the perfect breeding ground for these monster storms, but standard cloud cover actually limits a storm's intensity. Clouds cast shadows that block sunlight from reaching the ground, cutting off the heat that drives evaporation. The deadliest, most violent storms actually require completely clear, uninterrupted sunshine. Unfiltered sun bakes the Earth's surface, supercharging the warm, wet air that acts as the primary fuel for rapid storm growth. A flawless, cloudless morning is never a guarantee of a quiet afternoon. That wide-open blue sky is the vital thermal battery required to unleash millions of pounds of atmospheric violence.